Alright, so let's try to solve the problem right here. So we need to calculate 100 gram of water from 10 degrees Celsius to 110 degrees Celsius, right? What it says the required energies to go from 10 degrees Celsius water to 110 degrees Celsius water. Now we all know that at 10 degrees Celsius water is liquid and 110 degrees Celsius it's a gas, right? So we need quite a bit of information. First thing that we need is a specific heat. Specific heat of the liquid water is given as 2.087 joule per gram per degree Celsius. The specific heat of the water gas is 2.000 joule per gram per degree Celsius. And another thing that we need is what is the energy required to convert the liquid water to gas. That's the enthalpy of vaporization. That's 2257 joule per gram. So we start out from 10 degrees Celsius water, and then we're gonna heat up everything to 100 degrees Celsius. It's all liquid, right? And then once you hit 100 degrees Celsius, the temperature isn't gonna go up. At this point, the only thing you're doing is to convert liquid to gas. So from here to here, you have two phases, liquid and gas. Starting out with 100% liquid, and then you're gonna end up with the 100% gas here at the same temperature. And then once you convert everything to the gas, you're gonna heat up again to get to the 110 degrees Celsius. So this is a three-step process. Okay, so we do everything in the Excel. So let me see. It's that one. So I'm gonna take that things out. Alright, so let's do that. So I'm gonna hit the delete buttons to actually delete everything. So we start out with a 10 degrees Celsius water, right? But let's just say that I'm gonna need a specific heat. Specific heat of the liquid, H2O liquid. That's 2.087. Oops. So joule per gram degree Celsius. The same with H2O gas, the specific heat is 2.000 and joule per gram. Yep, that's good. So those two things we need, and then also we have enthalpy of vaporization, right? Delta H of VAP, enthalpy of the vaporizations. That's liquid to gas. That's 2257 joule per gram. Okay, that's pretty much all I need. And then the temperature, water temperature, starting temperature is 10 degrees Celsius. Start temperature is 10 degrees Celsius. And then the water boils at 100 degrees Celsius. So boiling is 100 degrees Celsius. and then end temperature is 110, right? And how many gram? The mass of water is 100 gram. Alright, so these are all the information we need to solve the problem. So this one right here is just the information sheet, so I'm gonna put some colors to it. It's good enough. Alright, so let's just do the step 1. So let's just go back to the so we are going to deal with this process going from 10 degrees Celsius to 100 degrees Celsius, right? It's all liquid. It's 100% liquid. Okay, so all we need, the heat required for the first step is the heat required is specific heat. The formula is this equal specific heat multiplied by the mass multiplied by the delta T, right? Just try to be completely consistent. So let's do that. Equal specific heat of the liquid water multiplied by the mass is 100 gram. Notice that gram is going to cancel. Multiplied by the change in temperature. Final temperature minus initial temperature. Final temperature for the first step is 100 degrees Celsius, right? Minus 10. That's the starting temperature. That's the heat required for the first step. What about the second step? So let's just go back to the now in the second step we're going from the 100% water at 100 degrees Celsius to the 100% gas at 100 degrees Celsius. So there is no temperature change. We're just simply converting liquid to gas, right? So for this particular case, only thing we need is the heat of vaporizations. It's actually delta H of vaporizations. Let me just try to delta H of multiplied by mass. So we need the delta H of vaporization multiplied by mass. That's it. And then the third step is, let's just go back to the previous one. Now we are going from the 100% gas at 100 degrees Celsius to the 110 degrees Celsius all gas, right? So we're changing only the temperatures. So once again, we are going to use the same formula of S multiplied by mass multiplied by change in temperature. but specific heat is different this time around. It's the specific heat of the gas, right? Multiply by the mass, multiply by the change in temperature. The final temperature for the third step is 110 minus the initial temperature for the third step is 100. So each one of these things are joule. So if you're interested in calculating the heat going from this step to go all the way from here to here, you need to have the heat required for that, the heat required for that, heat required for that, right? So you are going to add up everything. That's like 3 steps in a one shot. So total heat required is actually equal to this number plus that number plus that number, and that answer is in joule. And I'm going to put these things as yellow markers on. That's my answer to the question. That's how you use the Excel.